Oh, his internet wasn't dying. He was having dinner.
Yeah, that makes sense. All right, so I'm just going to talk about Java for a little bit, and then I'm going to show you the Eclipse window, and then I'm going to walk through some stuff. Again, like I said, if you guys want to uh, play with it on your own, I fully encourage that. I'll just go through the basics. Alex probably knows all of this. And at the end, I will save it as a text file and upload it to Slack so you guys have that as a reference. So what is Java exactly? So as you probably know, computers operate on uh, just zeros and ones, ons or offs, and a series of them make up messages and they send different tasks to the processor. But for us to make something do what we want it to do, i.e. a robot to go forward 10 feet, it's nearly impossible for us to code it in zeros and ones. It would be extremely difficult to diagnose it and change stuff. So what they did is they made different layers, and every time you go up, it becomes more human readable. So from the zeros and ones, you have above that you have assembly language, which can access different registers and read direct memory. Above that, you have what we would consider like Java, which when compiled forms assembly level code. And even above that, you can have something like Python or a scripting language, which then doesn't actually compile, but makes something that then gets compiled and stuff. And it can go down the list from there. So Java has some inherent advantages. It's very good at importing different classes from various parts of the internet, and it's very open. And beyond that, it can also be ported anywhere. So the internet back in the day was actually built for Java. Java was almost designed to be the perfect portable platform where you can design an app and then host it on a website, and it would be a fully functioning Java app. You don't need to have any dependencies, or it'll wrap it up in a nice little bundle, and then you can just load it onto a website. But that's why Java is used by about 3 billion devices so far, and our team chose to use Java, which is one of the 3 supported languages for the robot. So right now I'm just going to go over the basics. We're going to cover basic data types and loops and then conditionals. So let me show you Eclipse. So right now you guys should be seeing the Eclipse window. Let me know if you can't. And yours might be a little bit different. If it is, over here in the top right, there should be a Go to Workbench button. And once you click that, you should be seeing something here. So when you want to go make a new project, there's 2 ways to do this. You can go to File, New, and then hit Java Project. Or you can right-click over here on the left side, which is the Package Explorer. So basically, the overview goes like on the left side, you have your Package Explorer, where you can make projects, store different files in different packages. And over here in the center, you have where your actual code is going to go. And then usually down at the bottom or over on the right, you can have consoles and different windows. Generally, the only things that I care about are the Package Explorer on the left and the console down low, with your code obviously being front and center. When you first open Eclipse, it's going to ask you to show save a workspace, and that's basically where all of your code is going to be saved. So that's kind of trivial, but it's good practice to just save a lot of your code in the same place, because when you make any new projects, they're all going to be stored there, and you have one nice little area for all your code to be. So let's go ahead and make a new project. We're going to hit right-click in this Package Explorer, hit New, and then Java Project, and we're going to call this Summer Sections for Summer Sections. So if we go through here, it's going to go to the default location, which is our workspace. As you can see, for me, it's the path users, my name, desktop, workspace, etc., etc. And down here, this is why you need your JDK. What's going to happen is it's going to select an execution environment, which basically means if you want to run this, it's going to link to the Java that you downloaded previously so that it can compile and then run.
Sorry to interrupt. Your screen isn't updating for me. I don't see any changes. Your screen isn't updating for me. I don't see any changes unless you're outside of it.
Let me do that. So over here, do you see?
Oh yes, now I see everything.
Okay, yeah, I think it was just broadcasting the one window instead of everything.
Okay.
So yeah, so product name up here, default location is my workspace, and then over here is the different execution environments. It should be Java 1.8 by default. That is the latest version. And we're going to go ahead and hit next. And you normally don't need to hit next. You can just hit finish. I'm just going to show you everything. So if you want to go and explore, yeah, you can feel free to do so. So this is the package hierarchy that it's going to have. There's going to be a folder called SRC, which stands for source code, which is where we're actually going to start coding. You can link to different projects. You can compile different libraries, and then you can choose which order to import stuff in. So we're going to go ahead and hit finish. It's going to create our project, and now it shows up here on the left in the package explorer. So if I hit the down arrow, you can see the package hierarchy, and there is a source folder. So first thing we're going to do is right-click there. We're going to hit New, and then Class. The way Java works is when you make a class, it's basically the instance of that one file. And I'm going to show you that it's going to make a .java file, and we can, start coding in there. So we are going to call this intro. One thing to mention is the name of the class is also going to be the name of the file. So you're going to want standard naming conventions, which is no spaces. You can have numbers, or actually maybe you can't have numbers, but you're going to want no spaces and capital letters for every new word. So we're just going to call this intro to Java. Over here, we're going to want public. You don't need to worry about any of this stuff. And we're going to want a main. So the main is actually this function is where the compiler looks to start your code. So we're going to click that, and we can hit finish. So now you should see some code over here. One of the first things you want to do is right-click over in this gray bar and go to Preferences, Editor. Sorry, I'm just trying to find the line numbers. Oh, here it is, show line numbers. Okay, cool. So that just makes it easier to diagnose. You can say, hey, there's something on line 5 or something, and you know exactly what that means. So, like I said, this main is where your compiler is going to look to start your function. And the way code works is it goes from top to bottom and executes the commands that you type. So something to mention, if you have 2 forward slashes like this, it creates a comment. So if I type 2 forward slashes and say this is an example of a comment. So that's a comment. And then if I were to type anything outside of that, it's going to try to consider what it is as actual code. So right now it says, if I hover over something with a red dashed line underneath, it says it cannot be resolved because it doesn't know what it's talking about. It doesn't know if it's a variable, a parameter, a constant. So that's basically that. So one of the first things we're going to show you how to do is print to the console, which is an extremely useful tool. So the command for that is system with a capital S dot out dot print ln. And then we're going to type whatever we want in quotes. So this is a printed statement. One thing to mention, make sure that you have a quote in the front and a quote at the end of whatever you want to print. Or again, it's a capital S, and this should be in parentheses here. All lines of code in Java end with a semicolon, except for loops, but it's a good convention to just end it with a semicolon. So what's going to happen if I run this, which is this green button up here, if I click that, it's going to ask to save it. I'm just going to go ahead and hit always save resources before launching so that it always saves. It's going to run, and then down here in the console you can see that it printed. This is a printed statement. So let's talk about data types now. So one of the first things is an integer. So in the real world, an integer is just a whole number. And it can be negative, it can be positive, it can be 0, and that's the same functionality that it has in code. Integers can go from some -2 billion to 2 billion because they're signed. So the way you declare an integer is int. So you see how it's purple? It recognizes that as a data type. So the way you declare a variable is data type, variable name. So in this case, I'm going to call this my integer. And then you're going to write equals, and then some value you want to assign to it. So in this case, I'm explicitly calling my integer is equal to 5. You can also do it in 2 separate steps. So if I wanted to say my other integer, and I just put a semicolon, what that does is it allocates memory for it, but it doesn't assign it a value. But then I can come down here and say, oh, I mistyped that. I can come down here and say my other integer equals 7 or 6. No, I'll say 7. So in this case, we did it in 1. So initializing an integer in 1 line. I don't know how to spell it, but in this case it is declaring an integer, and here is assigning a value to an integer. A good common convention is to comment your code for anything you want. Something to note, if I just hit enter a bunch of times and there's a bunch of what we call this as white space because it's just nothing, Java as a language does not care. It'll just skip over all of the lines that have nothing on it and then go to the next line. So it makes it a lot easier to spread out your code into blocks. So if I want, here is my generic start, and then if I want to comment this block, I can say variable declarations. So if I ever want to look at where all of my variables are declared, I just need to go right here. So this is how you make integers. So one of the first things we can do is do some math with it. So let me make a system.printout. So if I just want to do 5 plus 7, right? If I just want to do some simple math, in between the 2 parentheses, I don't need to print what we call a string. This is a string because it's just like words. If I want to do real math, I can say, what is 1 plus 1? And it's going to print 2. So if I run this, you can see this is a printed statement, and then on the next line just printed 2. But if I want to do something with variables, I can then come in here. Instead of 1 plus 1, let's do my integer plus my other integer. And like you would expect, it's going to basically substitute in 5 for my integer and then 7 for my other integer, and it's going to print 12. As you can see down here, printed 12. So that's one of the first things we can do. So from there, we can go on to, let's go into doubles. So doubles basically act as any number. And what that means is it's not restricted to integers, and it can be some sort of variable between 1 and 2. It can be 1.2, it can be 1 point, any number of zeros, and then a 5, stuff like that. And the way you declare that is very similar to an integer. We just try the data type. So in this case, it's double. My double is going to be the variable name, and then we're going to call this 12.775. Like you can see, it's going to give me a warning just that it doesn't know what it is because it's not used. If you're ever wondering what any of the underlines mean, whether it's yellow, red, I think that's it, you can just leave your mouse over it and hover it, and then it'll tell you. So it says here the value of the local variable my double is not used, which we don't really care about. So what can we do with that? We can do the very same math that we did down here. We can then change this to my double. So now it's going to try to add 7 to 12.75. So as you can tell, this became 19.75. So if you add 2 integers, you obviously get an integer back. If you add an integer and a double, as you can tell, you get a double back. So let's talk about some other data types that are pretty useful. If you just want to know if something's true or false, there's a data type for that. It's called Boolean. As you can see, it's purple because it recognizes that. So let's call this is double, or is it a double. And we're going to initialize that to false. There's another one called a character, which in, I guess, layman terms would just be a letter. So we'll write that as char. So let's say char, my char equals a. And we use single quotes here. When you have a bunch of characters together, it becomes a string, which is a capital S. string equals. And this one is a little bit different. We have to write new and then string. And in parentheses, we can write whatever we want it to be in quotes. So this is my string. Again, semicolon at the end. So now if we want to test that, we can come in here and then just write my string, run it, and as you can see, it says this is a printed statement, and then this is my string. So if we want to change what my string is, we can say my string equals this is a different string. Here we don't need any parentheses because we're not assigning anything. The only reason you need parentheses here is because you're declaring a new object of type string, which is a little bit different from the regular variables, and I'll explain that when we go into object-oriented programming in a couple of sessions. But yes, so this is how you do this, and again, if we run it, we can say that this is a different string. So one of the most important things in programming for robotics is using multiple variables to basically keep track of what's going on. In the first session, I talked a lot about, making sure how our control system knows what's going on with its environment. Otherwise, it's just a black box that just sends commands to the environment. But with a lot of sensors, you can then control what's happening. So the way you keep track of sensors is with variables like this. So it's very easy to keep an integer or a double of my elevator height and just read from a sensor, and then you can use that variable elsewhere in your code to do different things. And the main way we do change execution is with what we call conditionals. So, and again, stop me if you have any questions, but the way we execute a conditional is you basically think about what you want to happen. So right now, I want to do some math, right? Let's make a new variable over here. Let's say this let's call it double my result equals my double times 2. So I basically want to see what happens if my double is greater than 20 or if it's less than 20. And again, the words I'm saying is if it is greater than 20, I want to do something. Otherwise, I want to do something else. So let's change this boolean to is over 20. So that way we can see how to execute this. So the way I'm going to write that in code is if, I'm going to put a parenthesis, and in between these two parentheses is where you're going to put what we call the condition. So the way we do that is my result, and then we're going to say greater than 20. And you can use various different things here. So let's see, we can use that for greater than or less than respectively. If you want to do less than or equal to, do that, greater than or equal to. If you want to see if one value is equal to another value, you don't use a single equal sign, because a single equal sign is used for assignment. Like you can see here, it says like my double equals 12.75. For evaluation, you use two equal signs. So that's like, is it explicitly equal to a separate value? If you want to do not equal to, we use the exclamation point and then the equal sign. And if you want to say like, if you want to combine multiple expressions together. So if I want my result is greater than 20 and something else, then the way you do that is with 2 ampersands. You can also do OR, which is 2 vertical lines. That is the key above the enter. You just hit shift and then click that. I think it's the backslash. And you get 2 vertical lines. So that is how you do OR. So right now we have if my result is greater than 20. Then when you have a conditional statement, you use curly braces to basically block off the section of code. And if you can tell, it kind of indented in. So something to note that it has the class surrounding our main statement, and then we have an if. So all these statements kind of nest inside each other, and that makes it very easy to organize. So right here we're going to say if my result is greater than 20, I want to set this boolean to true. So let's write is over 20 equals true. Semicolon. And then what did we decide? If it's false, then we want to do something else. So the way to do that is you write else, and the else statement doesn't take a parameter or a condition. You just write else because it auto links to this if statement. So down here we want to say is over 20 equals false. And semicolon. Forget about that. So down here, let's get a little bit interesting. Let's format our print statement so it's a little bit more readable. So I'm going to make a string in the beginning that just says is our result greater than 20 question mark. I'm going to put a colon and a space, and then I'm going to hit plus is over 20. So it's not actually going to add these two things together. What's going to happen is it's going to convert, since this is in a print statement, it's going to convert is over 20 to a string, and then when you have two strings with a plus, it's going to concatenate them together, which basically means it's going to stick the second string right to the end of the first string. So let's see what that looks like. Is our result greater than 20? It says true. So again, the value of true in a Boolean is just a 1 or a 0, versus the value of true in a string is much different. So that's something to note. So how can we do iterate over code? Let's say I want to print my name 10 times. Well, I mean, it would be very tedious to just copy this 10 times, but well, I guess for 10 it doesn't really matter. But if I want something to happen 1,000 times or 10,000 times, then copying and pasting it's going to be extremely annoying. So the way we do that is with a for loop. The way we write that is for, again we use a parenthesis. Inside this two parentheses we're going to have three different things. We're going to declare a variable, and let's just call it I equals 0. That's going to be our starting point. Semicolon, I is less than, let's write 10. So it's going to, this is our ending condition, or this is our condition for while this for loop runs. So it's going to continue to run while I is less than 10, sorry. And then our iteration. So we're going to write I equals I plus 1. So every time through this for loop, it's basically going to increment I by 1. So when you have something like this, when you say I equals I plus 1, in pure mathematics, that would be very bad. But in code, it evaluates the right side of the expression and then assigns it to the left side of the expression. So if, say, I is 3, when it comes to this line of code, it's going to say the variable I equals 3 plus 1. So it's going to change I to 4, and then it's going to jump back to the beginning of the for loop. Again, we're going to use curly braces here. And in here, let's write a print statement. One thing to note, if you are on, I guess if you're using Eclipse, which you're by no means required to, Eclipse is just what first supports. There are some shortcuts that you can use. So if I just type in sys out and then hit control space, it changes that to system.out.println and writes that whole thing for me. It makes it a lot quicker. So I'm going to write my name. Let's see what happens when we run this. Here it says this is a print statement. It prints my name a number of times, and then it says is our result greater than 20. But there's no way for me to tell exactly how many times it printed this. So let's go ahead and write plus I so that we can see, how many number of times it printed. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I wanted it. So that is actually 10 numbers because it starts with 0. But what if I wanted to print Pratik 1 all the way to Pratik 10? So the way I would change this is I would start at 1. I want it to run while it's less than or equal to 10, and I can keep this the same. So if I run this, starts at 1 and then ends at 10. Well, what if I want to do every other one? So let's do the odd numbers. So it starts at 1, it ends less than, does it want to end less than or equal to? No, I just want to end less than 10 because I don't want to include 10. And here I want to say I equals I plus 2. So that way it'll start at 1, and then the next time it comes up, it'll be 3. So let's run that. Here we go, 1, 3, 5, 7, 9. And the odds would be the same way. Change this to 2. That can be less than or equal to. And then you can keep that change the same, and it goes 2, 4, 6, 8, 10. Great. So a lot of code is very repetitive, and the way we make that easier to read is we declare a function. So the way you use functions is you make one instance of it, and then you can copy it to various places and use it for various different scenario. It's almost like a generalization. So I have these two. I'm going to actually comment all of this out because I don't want it. So the way I just commented all of that very quickly is you highlight what you want to comment, and you can hit Control / or Command / if you're on a Mac, and it basically just writes the comment sequence. And when it goes to compile, basically it skips over anything that has those two / on it. So right now I have a couple of integers, a double, a boolean, and my result. So let's make a function do some simple math using two numbers. And let's do just the sum, the subtraction, the product, and the difference. So the way you make a function is you first determine what it's going to return. If you want it to return something, you type in the data type that it's going to return. In this case, we're going to want to do a double. And then we're going to write the name of our function, so my sum, parenthesis, any inputs you want. In this case, we want double, or let's just say, this one I want to add an integer and a double. So int a, comma, double b. If you have a function like this, you can have any number of different inputs. What does it say? Okay, it's just complaining because it doesn't have a return type. So in here, you can have any number of things you want, just separated by commas. Again, this is the name of the function, and we're going to write curly braces. Something to note, you want to do this outside of the main statement, because the main in and of itself is a function. So there's a curly brace there to start the main, and then this is where it ends. So outside of that, but within the class, which is up here, we're going to write our function. So what do we want it to return? Return a plus b. So it links up the double in the return because it's going to return a plus b. And how do we use that? So let's go over here and say my result equals my sum, parentheses, my integer, comma, my double. Why is it angry? Oh, sorry. So one thing to remember, sorry, I've completely forgot about this. When you make a function here, you have to determine if it's going to be public, private, protected, and that's pretty much all you need to worry about. So we're going to make this public. Is that what I want? All right, we're going to make it static, just because. Basically, that allows you to write my sum instead of intro to Java dot my sum. But public means that it can be accessed outside of this class. So if I incorporate this into a larger file or a larger project where there's multiple files, I can call functions within this. Static basically means there's just going to be one instance of this. So if I have another my sum, it's going to overwrite what this my sum is. And over here, I'm going to want to print. So again, sys out, control space, and I'm going to print my result. And it prints 17.75, which makes sense because my double is 12.75 and my integer is 5. And you can do this any number of times. So anytime I want to add an integer and a double, or if I want to add, if I want to change this to a double, I can add a double to a double. And I don't need to actually change anything over here. This is particularly useful if I'm trying to do a very specific calculation multiple times, or I want to run one block of code a lot of times. So let's see what happens if I run this. Oh, I thought it would be. All right. Yeah. So that's pretty much right here. Intro to Java. And again, this isn't exactly everything you need to know. This is, glossing over a lot of stuff, going very quickly, but this, I hope, shows you exactly what you need to know to at least read through our code. There might not be a lot of comments in our code, and I'm going to clean this up before I post it on Slack, but comments are very helpful for explaining what you're trying to do, and I encourage you to use them very often. But this is the basics. From here, I guess next steps can be writing your own function. So if you care to go above and beyond, I guess you can, let me think. You can write a couple of functions to, given 3 values, calculate their average, the max, the min. Actually, let's do that. So let's make 3 values real quick. We'll just call this int A equals 10, int B equals 13, and int C equals 23, right? So I want to write 3 separate functions. I want to find the average, I want to find the max, and I want to find the min. So let's go about doing that. So I want to write a function, right? So first thing, public, because I want to be able to access it, static, and what do I want it to return? I want it to return double. Let's just call this calculate average. And we're going to take in 3 integers, so we'll just call this int value 1, int value 2, and then int value 3. And we use curly braces to denote that. It's just going to give you an error because it doesn't have anything returned. So how do you mathematically calculate an average? Well, you add the values together and divide by how many there are. So we're going to write a quick double average equals value 1 plus value 2 plus value 3, and then we're going to divide by 3. And again, you can use parentheses. You have a question? No, never mind. Okay, so you can use parentheses to execute code. Code follows the standard PEMDAS syntax where it'll execute within the parentheses and then move its way out. But other than that, it goes left to right. So it does not do. So if I have like a statement that just like something plus something times something, I believe it executes in the PEMDAS, but just use parentheses if you want to explicitly do things in order. It makes it a lot easier to both read and diagnose if it doesn't do the calculation you want to do. So right here we calculate the average, and we want to return that. Return AVG, semicolon. So now up here we can system.out.println calcu average, and then we're going to pass in A, comma B, comma C. So again, we don't write int A because that would declare a new value. Did I type that wrong? Yeah, I typed it wrong. So it's going to print what the average of those 3 values is, and it's exactly 15. Yeah, that makes sense. Or does it? 23 plus 23 is 46. 46. I guess it might not. No, that makes no sense. Oh. So what happened is I'm adding integers and dividing by an integer. So that's going to make it, auto truncate. So if I divide by 3.0, I should get a more accurate, there we go, a more accurate value. So that's something that you need to do a lot when you're programming is run it, test it, change it. And that iteration is very important when you, go to do various things, because you write something, you have to make sure it works, and if it doesn't, you go back and change it. So the reason it didn't do exactly what I wanted it to do before is I have 3 integer values, and when I add them together, it creates an integer, like a larger integer, and then before I had it as just 3. So if I divide 2 integers, it returns an integer. Even though it's in code declared as a double, it's an integer in the sense that it first calculates the value as an integer and then just saves it into the memory allocated as average. So that's why it just said 15, even though the correct answer is 15.3 repeating. So let's go about doing the max and min. The max and min are going to be pretty similar. So public static, would we want to return an integer, since you're passing integers and you're receiving integers. Then we'll say calculate min. We're going to have our three values, and then we're going to, curly braces to section off the code. So what's the easiest way to determine the min? Well, I need to check value 1 against value 2, I need to check value 2 against value 3, and I need to check value 1 against value 3. So let's just assume that value 1 is the minimum to start. So let's just say int min equals value 1. And now, if value 1 is truly less than value 2, then then min should change to be value 1, or it should be assigned. But if value 2 is greater, then it should be, or value 2 is lower, then it should be value 2. So let's do that. If value 1 is less than value 2, then I want to say min equals value 1. Else min equals value 2, because that would mean value 2 would be less than value 1. So down here we want to recalculate the min. So that did one of our checks for us. The other check we want to do is value 1 against value 3. So if value 1 less than value 3, and again I want to do min equals value 1. Else min equals value 3. So that's our second check, and then our final check we're going to write if value 2 is less than value 3, then we're going to write min equals value 2. Else min equals value 3. And at the very end of this function or method, we're going to return the min. That it just sends whatever the min was back. Let's see if this works. Calculate min. Okay, and then we're going to run it. And it printed 13. Is that truly the min? Well, of these three values, it's not. So let's go ahead and diagnose why that happened. One of the biggest things you can learn in code is using breakpoints and going through your code. So you see this gray bar over here on the left side. If I just click, let me toggle a breakpoint. So that little ball means that it's going to go into debug mode. So when I run this, maybe I have to run in debug. Nope, that's trying to build it. Let me stop that. How do I Oh, right, you click the little bug. Instead of the run button, you click the bug. And what's going to happen is it's basically going to jump to this other perspective. So what happened is it ran our regular code, which is up here, until it got to this breakpoint. And now it's there. And within the function, we can see our three values, and what we can do is we can step through our code iteratively, like line for line, and see the values change. So right now, let's step over. So right now, min got assigned to value of 10, which you can see up here, which is right because we, assigned it to value 1. So if value 1 is less than value 2, which is true, we know that, then it should assign min to value 1, which it did. It didn't even go into the else because the if statement was true. So now it goes into the second if. Is value 1 less than value 3? Yes, it is. And I reassigned value 1, or min to value 1. But down here, it checks if value 2 is less than value 3, which it is. So now it's going to assign min to value 2, which is why min was 13. And it shows you that something changed by highlighting the yellow. So now let's go all the way to the end, and it returned min. Okay, well that makes more sense. So let's stop this. And over here, if you click Java, it'll jump back to the primary, format of the windows. So how do we change this to make it so that, it does what we want it to do? Well, how about we check them, instead of doing them one after another, why don't we check them within themselves? So if I just cut this and then paste it here, instead of the min equals value 2, it's going to say if value 1 is less than value 2, then assign it that. If it's not, let's check if it's less than value 3. Or actually, yeah, there's a much better way to do this. Let's combine these. So let's say if value 1 is less than value 2 and value 1 is less than value 3, then we know the true minimum is value 1. Because if this part is true and this part is true, then value 1 is the lowest of those two. But if this one is true or this one is false or the other way around, then it'll go into this else. So else, so instead of checking them, iteratively like this, yeah, what's up?
What's the symbol for or?
Oh, I mentioned it up here. The way you do that is you do 2 vertical lines, which is, I forget, there's a name for that symbol, which I don't know, but it's the key above the enter. So
okay.
So you do 2 of those in a line.
Thanks.
Yeah, no problem. So else. So instead of doing a regular if-else, we're going to do a more complicated if-else tree. So else if basically is I want to check one condition, and then I want to check another condition, and then I can check any number of conditions, and then at the very end I have an else. Let's do else if, and then if I do an else if, basically it's going to check this. If that's not true, it's going to come down and check this. Again, if that's not true, all the way to the, and then depending on how many we have, all the way at the very end, it'll go into the else. So since there's an if, you have a condition here. So we're going to say value 2 is less than value 3, and value 2 is less than value 1. So again, this is doing the same calculation or check that it's doing up here, except just with value 2. Then that means the minimum is value 2. No, that's what we're on. Semicolon. So if both of those are false, then the only one left is value 3. So if I do else, I can say min equals value 3. Let me get rid of this code and delete this just to clean it up. So let's go through this again. We assume that the minimum is value 1, which we actually don't need to even do anymore. Or I guess we do, since we have the variable. But let's just keep it in for now. So first thing we check, if it's less than value 2 and it's less than value 3, then we know the minimum is value 1. If value 2 is less than value 3 and value 2 is less than value 1, then the minimum is really value 2. Or if neither of those two things are true, then the minimum value is value 3, and then we're going to return that. So let's go ahead and try this. We're going to run it, and it says 10. Is 10 the true minimum? It is. So what happens if I change B to 10 and A to 13? I run it, still says 10. So we know that it's doing the correct calculation. Let's see. So yes, you can actually convert this to calculate the max very easily. And let me go ahead and get rid of this breakpoint. But again, we would just change all of these to greater thans rather than less thans. Yeah, so that's basically it for your intro to Java. Next week, we're going to cover, I'm going to talk about object-oriented programming. Do you guys have any questions?
Not really. I'll just review everything when you put it in Slack. I think that's about it.
Yeah, I'm just going to clean this up with a lot more comments, and then, let's see. Yeah, I'll clean it up with comments, and then I'll post it in Slack as a text file, So you guys can just, copy and paste it into your own thing. So next session is going to be next week, and we're going to start doing object-oriented programming. In the meantime, if you have Eclipse and have the JDK, I do encourage you to, play around, think of something that you want to program, maybe some calculations. One of the first things that I did was make a grade calculator. So given, my various weights, so like homework would be like 10% of my final grade, and then final project might be like, I don't know, 20, stuff like that. Basically, I made a Java program that just calculated what my final grade would be or what I needed on the final, and then, just I entered in what I had in each of the different categories, and then it calculated my final grade. So if you guys want to do something like that, feel free. You guys are more than welcome to, experiment and ask me any questions as you go along. If you send me any code, I can, help you debug it or, try to optimize it if you need. But yeah, that's pretty much it for this session. Next session should be next week. We're going to cover object-oriented programming, which is a little bit more complicated, so that might take 1 or 2 sessions. But that'll be next week. And again, I think we're going to do these on Fridays, since Thursdays is when you guys meet in the shop. So that's about it. Thank you guys for coming. And again, I'll post all of the code to Slack after I clean it up.
All right. See ya.
See ya.
Thanks.